is basically positive. So please remember, guys, what is power? Power is basically the converging or diverging ability of the optical device. More the magnitude of power, more will be the converging diverging ability. In this case, it is converging more. In this case, it's converging less. Hence, power of this lens is more than this. In this case, it's diverging more. In this case, it's diverging less. So hence, the power of this lens magnitude only. Please remember the magnitude we're talking, right? Sign will decide like this. Is it clear? The SI
Yes,
unit
sir.
of power is basically diopters. This is not mechanical power. This is optical power, है ना? It has a different units, diopters or per meter. One diopter is basically what? 1 per meter. Is it clear? Is it clear, guys?
Yes, sir.
Okay.
Yes, sir.
Now please write combination of lenses. Suppose if I have many lenses and if I try to give you what is the combination of these particular lenses, suppose there is one lens like this, another lens like this, there is one lens which is like this, and then one more lens like this. So can you see there are four lenses? One over here, the second is over here, the third is over here, and the fourth is over here. So can you see there is a combination of these lenses, and all these lenses are placed very nearby to each other. Lenses are placed next to each other. Okay, so please remember there won't be any distance. You'll consider this as a one optical device, and suppose if I say the focal length of this is f1, the focal length of this is f2, the focal length of this lens is f3, and the focal length of this is f4. If I want to combine all of them to a single optical device, it can be a concave lens or a concave mirror depending upon the focal length. So if I want to find out if what is the combination of all the lenses, then I'll say the power of the combination is basically R net. If you remember, R net is equals to R1 plus R2 R3, right? So P net is basically P1 plus P2 plus P3 and so on. Similarly, what will be the net focal length of this combination? It will be equals to 1 by f1 plus 1 by f2 plus 1 by f3 and so on. Is it clear, guys? But the
Yeah.
magnification, I'll just write the formula. The net magnification created by every all of them is basically the magnification multiplication. Basically, the multiplication of magnification produced by individual one. Okay, ये standard results हैं तो लिख लो. Is it clear? You understand what will happen when you will combine 2-3 lenses, right? Okay, is it clear?
Yes, sir.
Now question, a lens has a power of +5 diopters in air. What will be its power if completely immersed in water? If it is completely immersed in water, then what will be the power? How will you do this? Already we have done this type of question, right? Do you remember 1 by focal length in air is equals to by this thing? If I say the refractive index of the lens is mu, refractive index of glass is given 3 by 2, and refractive index of water is given 1. Oh, sorry, 4 by 3, and refractive index of air is given 1. Okay? Hello? So you
Yes,
know
sir.
how will you do this question, right? In air, if it was placed, then 1 by focal length in air is equals to 3 by 2 divided by 1 minus 1 mu. Do you remember? If it is in air, then glass and surrounding is air. So surrounding in denominator. And this will be 1 by R1 minus 1 by R2. And what is this given? What is this? 1 by FA is basically what? The power, right? So this is plus 5 given to you. Similarly, if it is in water, then 1 by F water will be equals to, and this is the P dash which you want to find out, right? So I guess you people can do it easily. Already we have done this type of question. Divide 1 into, so you get P dash. Is it clear? The answer will be 1.25. Okay, plus that to plus. So hence still it is behaving as a converging unit. Anyways, I think you people can solve it, right? I'm not wasting time on solving this thing now. Next question. A 5 diopter lens forms a virtual image which is 4 times the object. Now the question is find the easy question. You can do it. Distance of object from lens. First of all, read the question carefully. Understand which case it is this is talking about, and then we'll try to do it. Hmm. First of all, can you see there is a lens forming virtual image which is 4 times the object? Is there any lens which forms a virtual image as well as which is magnified, virtual and magnified, right?
Yes, sir.
So can you identify this case? If image is virtual and magnified, then which case am I talking about? Am I talking about convex lens, object between
O and P.
F and O, right?
F and yes, sir.
So basically that is the case. So convex lens hai, so power is positive plus 5 diopters. If power is this much, then I can find out what is the focal length. 1 by F is given, right? This is basically 1 by F given to you. Aaya na? But please remember the answer is in meters. Hai na? Now, can you see over here when this case is there, even HI is positive and even HO is positive. So can I say this particular thing here? The magnification is plus 4. So can you see from just the question, we are trying to determine what is the sign convention, right? So magnification is plus 4 and we know M is equals to plus V by U. So hence M will be equals to what? And what do you want? This is plus 4 is basically plus v by u. So can you see over here v will be basically 4 times of u? Yes or no? Will the image distance be basically 4 times the object distance? आया ना? So basically इतना analyze करना आना चाहिए अपने को. If the object is over here, the image is forming somewhere over here. This distance is basically 4 times of the object distance. So if object distance is u, then ये तुम लिख दिया अपन. Already we have written v is basically 4 times of u. So this is the magnitude part. Any doubt in this, guys? Guys, any doubt in this?
No, sir.
No, sir.
Once you have done that, you can apply by Lenz's formula. 1 by f is equals to 1 by v minus 1 by v. So 1 by v is basically 4 times of u with a minus sign. Now you have to put the sign to minus 4u minus minus u. Sir, why are we putting u negative? Because this was just how to calculate the magnitude. This is magnitude of u is basically 4 times. And 1 by f was given plus 5. So you people can solve, right? Guys, when you will solve, the object will be, the object distance will come 15 centimeter. Okay, u will come, the value of u will come 15 centimeter. That implies this distance is basically 15 centimeter, and that's the answer. Anyways, try to solve it. हो जाएगा. So guys, these are the questions which are based on power. Basically, we just added one more thing. Is it clear? Any doubt? Is it clear, guys? Now let's see. Acha, please remember, I told you the lens maker formula is only valid when the medium on both the sides is same, right? Now suppose if I have lens in which you have different medias on both the sides. So suppose this is our lens, this radius is r1, this radius is r2, this is mu1, this is mu2, and this is mu3. What is mu I? Mu1 is basically what? The where the object is placed, right? So it's basically the medium of incident rays. Mu2 is basically where the refracted ray will be. So I can say it is basically the medium of refracted ray, and mu3 is basically where the emergent ray will be. So mu3 is the medium of emergent ray. Is it clear, guys? Guys, you understood what is mu1, mu2, mu3? Yes.
Yes,
So
sir. Yes, sir.
suppose if the object is placed at a distance u, and let's say in the first surface its image is formed where, let's say, I dash over here at a distance v dash, and the second surface forms the image over here at a final distance v, then again I can use the same lens maker's formula, but what will be the difference? For the first surface, if I use the formula for single spherical, then it will be mu 2 divided by v dash minus mu1 divided by v is equals to mu2 minus mu1 by r1. And for second surface, I dash will be acting as the object, right? But can you see the refracted rays will be in medium number 2? So what will you do? Mu2 divided by v dash. This will be where the image is found in image number medium number 3. So mu3 by v is equals to mu3 minus mu2 by r2. So basically, when you will add both the equations, you will get this mu2 by v dash will get cancelled out. It will be mu3 divided by v minus mu1 divided by u is equals to mu3 minus or mu2 minus mu1 by r1 plus mu3 minus mu2 by. So basically this is your formula for when the medium is different on both sides, then this is the modified lens maker's formula for different medium on both sides of the lens. Is it clear, guys? Is it clear?
Yes, sir.
Okay. Please write it down. Once you're done, I'll give you one question based on. Still guys, अभी भी मैंने ना जेई मेंस एंड नीट का यू नो सॉरी जेई एडवांस पोर्शन हटा दिया. अभी still I'm teaching you till mains and neat level. Okay, I have removed the advanced portion as of now, in which there was velocity of the object, velocity of the image. I gave velocity of image only for plane mirrors, right? Due to time crunch, I had to leave some things and move forward. So we'll discuss them later on. Don't worry. Once we are done with the syllabus and everything, we'll be doing that as well. ठीक है? चल. Question. There is this lens given to you. The radius of this, it's a plano-convex lens. The radius of one surface is given 10 centimeter. On the right hand side, I have water. On the left hand side, I have air. Then this is made up of glass. The question is, where in the air an object should be placed? Please remember, I need to place the object over in air, है ना? So that uh, the light rays in water become parallel to optical axis. Is it clear? So question is basically this: where shall an object be placed? In air, let's say at a distance x. So you need to find this x. So at a distance x, an object shall be placed so that the final rays which are coming out of this surface are basically parallel to the optical axis. This is what the question is. How will you solve this type of question? Can you see the object is placed at a distance minus x, right? Yes or no? Guys, object is placed at a distance minus x. The final image, where exactly is the final image forming?
Infinity.
Infinity. What is the medium of incident rays? Incident ray, refracted ray, emergent ray. What is the medium of incident ray? Air.
Air.
What is the medium of refracted ray? Glass.
For glass.
And the last one is emergent ray will be water. Right? Apart from this, what is the value of R1 given to you? Can you see R1 is positive 10 centimeter and R2 is again infinity because it's plane, right? So I can apply that equation. 4 by 3 divided by infinity minus 1 divided by minus x is equals to, can you say over here, mu 3 by v minus mu 1 by u, okay, is equals to this medium minus that medium, 3 by 2 minus 1 divided by the radius r1. R1 is basically how much? Plus 10 centimeter plus, can you see, plus mu 3 minus mu 2. So basically this minus that. So 4 by 3 minus 3 by 2 divided by infinity, because the radius was infinity. So this will become 0, this will become 0. So from here, can you see 1 by x is basically 1 by 2 divided by 10. And from here, x is basically 20. That's the answer. Is it clear, guys?
Yes, sir.
Hmm. Please remember, guys, the one formula which I gave you for combination of lengths. No, do you remember this? It's only valid for thin lenses. Why it is valid for thin lenses? Because of the assumption lenses are placed next to each other, right? If they will be thin, then only you can consider as a common optical device. So, anyways, is this question clear?
Yes, sir.
Chal. Last heading of this thing is basically cut length. And last नहीं, इसके बाद there is one combination of thin lens and mirrors, but that is we'll do later. मतलब that is very advanced portion. So anyways, that is mains, but not as of तो कोई बात नहीं. So cut length. So guys, suppose there is case one. If I have a lens like this, and if I cut it like this, so basically when I cut it like this, what will happen? This lens will be divided in two parts. Yes or no? So when I cut it like this, if I, this is a catchy, this is a scissor. So if I cut the lens like this, then will it become like two pieces like this? This will be a lens one, this will be lens two, right? So basically, tell me what happens when you cut the lens like this. If I suppose if I use this as my lens and this as my lens, then what will happen? Can you see over here when I cut the lens like this, did I change the radii? The radii which were there in the previous case, did I change the radius? The radius is still the same, right?
Yes, sir.
And can you see the medium is also same? So here, when you cut the lens like this along the optical axis, then there is no change. If we cut it along optical axis, then no change in the focal length or radius of curvature. Okay. But please remember what will happen. Basically, if you will use this to form the image will be less bright now. Why it will be less bright? Because the portion of light which was coming from the bottom of the lens is not there. So it will be less intense. The intensity will decrease, right? The intensity of the light the intensity of the light, or basically not the light, sorry, the intensity of the image will decrease by 50%. As it was cut from the middle, as the lens is cut from the middle, then it will reduce by 50%. You don't have, cases when, it is cut from any one particular place, right? You have only cut from the middle. That's it. Even school level, J level. So the intensity of the image will decrease by 50%. Is it clear? Case number 2. If I cut perpendicular to the optical axis, again I'll cut it, from between only. Now, suppose if there is a lens like this, and if I cut it from here, if I cut this lens from here, so this is the radius r1 and this is r2. If I cut it from here, it becomes, one becomes like this and another becomes like this. Can you see? If I cut a biconvex lens from this like this, then what will happen? It will become, two lenses will become like this. But can you see these two lenses are what? Plano convex, right? Can you see when I
Yes,
cut it like this, I have changed the radius of the two surfaces now. One surface is same, but can you see the other one is different? Are you getting my point? The radius of this surface, I made it at infinity, right? The plane surface is infinity. So for individual lenses, the focal length will change. It will become f1 and it will become f2. Okay. So here focal length will change as the radii of curvature of the cut lens are different. So since it is changed, so I can say even the focal length will change. And how will you find out the focal length of this lens? Again, it can be find out using lens maker's formula. This can also be find out using lens maker's formula, right? Yes or no? F1, F2 can be find out using a lens maker's formula, right? Yes or no?
Yeah.
But still, there will be a relation between these three focal lengths. What will be the relation? 1 by f will be equals to 1 by f1 plus 1 by f2. Can you see, if you place these two close to each other, it will become exactly like the previous one, and you can use the this thing, combination of lengths, right? Yes or no? So 1 by f1
Yes, sir.
will be equals to 1 by f1 plus 1 by f2 for biconvex lens. But if you have an equiconvex lens, if I have an equiconvex lens, then these two lenses will be symmetrical, right? So in that particular case, 1 by f will be equals to twice of f, and from here f1 will be equals to 2f. So always remember, on cutting a equiconvex lens or a equiconcave lens, the focal length doubles. Is it clear? Is it clear, guys?
Yes, sir.
ठीक. Acha, guys, tell me this particular thing. Do you have dispersion in your syllabus? In school
Yeah,
syllabus? Huh?
we do.
नहीं, dispersion में, the dispersive power, dispersion without deviation, all that stuff.
Yes, sir. No, I don't think so.
Let me check this.
Dispersive power is not there, I think.
So there is nothing. NCRT grade 12. एक second. Just let me download the book. Don't have it as of now. Just give me 2 minutes, guys. Class 12. Select subject. Is physics. Subject. Oh, it's in part 2, right? Guys, this is in part 2, right?
Yes,
Yes,
sir.
sir. Yes, sir.
मैं तो भूल गया यार. And which chapter?
Wave optics.
अरे नहीं रे, number.
The second chapter in second book.
Second chapter in second book. Okay. Let me just 2 minutes लगेगा मेरे को. Let me see the. Yeah, this is wave optics. First chapter it should be there.
The second chapter.
Second chapter is wave optics.
Yep.
So I want first chapter. No, we are still doing wave optics and optical instrument.
Oh, my bad.
We did combination. We did refraction through a prism as well, right? Hey, you don't have dispersion, like the dispersive power and all. So we'll be leaving that. Wow, nice. We'll do it later on. Guys, you don't have dispersive power and all, so directly you have optical instrument. So you can leave this much up, guys. I am done with the syllabus as of now. Matlab, ray optics part is done. Optical instruments I need to do now. So how many pages you will leave after this? Let me just calculate. One is for displacement method. So 1, 2, 3, 4, 5 pages for 4 pages for displacement. 1 page for more numericals. Guys, leave 5 pages again, guys. Leave 6 pages, 6 or 7 pages, because I need to teach you velocity as well, right? Leave 7 complete pages, guys. Guys, leave 7 complete
Okay, sir.
pages. After this, what is the topics to be taught? First is basically the displacement method. Then longitudinal magnification. And guys, did you leave some space in when we discussed the single spherical surface? Magnification, sorry. Velocity of image in case of single surface, single spherical surface, length as well. Then fourth is the dispersion, complete dispersion. Guys, the dispersion which you have in your notebooks is the basic one, right? Dispersion is basically the breaking of light into 7 component colors with gear and all. So it's completely theory. You won't have problem dealing with dispersion of school level. Right? The rainbow is basically based on dispersion only. So read those in your school notebook. Dispersion I am leaving as of now. So okay. So guys, leave 7 pages. For advance. Mains and neat is clear. Na? Achha, by the way, this is also on mains and neat. This is also mains and neat, but abhi I'm not teaching it as of now because I want to move on to the next thing. Is it clear, guys? Please write down the heading optical instruments. Guys, please write down new heading optical instrument. We'll complete the remaining chapter, don't worry. Maybe I need to do, give a lot of things to you in ray optics itself, but time is not allowing because I need to start with wave. I need to complete your syllabus before November. मतलब नवंबर एंड से पहले पहले. Anyways, optical instrument, guys. Basically, what are optical instruments? These are devices which utilize the phenomena of reflection or refraction for image formation in various objects, right? So basically, those are basically your optical instrument. The most common optical instrument which we study are basically the human eye, the simple microscope, third is compound microscope. Guys, can you see over here? There are some devices which are called as microscopes and there are some devices which are called as telescopes. I'll ask you the difference between them later on. Prepare with your answer. Refracting telescope, then you have reflecting telescope, then you have terrestrial telescope, and the last one is Galilean telescope, also called as astronomical telescope. Yes, guys. Can anyone tell me the difference between microscope and a telescope? What is microscope used for?
Measuring microscopic objects, like which
Or
are very
basically,
small.
can I say this particular thing? Enlarging the images. For very hard, or you can say hard to see objects, right? For small objects, right? Yes or no? Enlarging the images for small microscopic objects, right?
Yeah.
Microscopic objects, not necessary microscope में cell ही वो सब देख रहे हो, no, not necessary. You can just zoom into a insect, cockroach चल रहा है और उसके लिए ऐसा you can just have a simple microscope, magnifying glass, and see how exactly it is. So basically you see through it and you see an enlarged image, right? And what is a telescope, guys? Telescopes are generally used to again enlarge the image of objects far away from us, right? So basically, suppose if there is an object which is far away from you, so it will look very small to you. Yes or no? Just take an example, sun. Sun is huge, it's massive, but it looks very tiny from here as seen from Earth, right? Ayana.
Yes, sir.
So basically, what is if the object looks tiny, so basically again we are using the same concept to enlarge the image only, but this object is far away from us. So basically, for observing the object which are away from us, we use telescope. है ना? Is it clear? Is it clear,
Yes,
guys?
sir.
Microscope and
Yes, sir.
telescope basic meaning समझ में आया? Now let's start them one by one. First is अरे यार, shall I teach you I? I 9, I know that. ठीक है. So in here, first optical instrument is basically human eye. We all know what human eye is. Your homework is to draw the human eye. You can take the reference of your 10th grade notebook. Draw the human eye, its construction, its working, and its parts. Construction is basically what are the different things inside the human eye, right? So all of this is given in your 10th grade notebook. Yes or no? In short, I'll explain to you. Uh, Whatever light rays which are coming from the object enters through your eye from something called as what? Enters inside through iris, right? Yes or no? Iris has a small hole inside it, and that hole is basically called as a pupil. Shall I explain you human eye? It's fine. 10th grade में सबने पढ़ी है. And basically what happens then after this, there is the lens. What happens to the lens? The lens refracts and the image forms on the retina, where the retina, retina has two different type of cells, rods and cones. Rods help you to adjust the contrast, whereas cones helps you to see the color, right? Or it's the other way around, I don't remember. So but still, you can get information about the image, and that information is converted through the retina cells, and it is converted to electrical impulses which is sent through your optic nerve to the brain, where the brain interprets the image, right? So the whole construction, that is basically an homework part for you. One more part of the homework is basically called as the accommodation of eye. This is also what you might have learned in 10th grade. If you want, I can provide you with the PDF NCRT for 10th grade chapter, or you can download it on your own. Guys, what is accommodation of eye? चलो ये पढ़ लो because it's important. Sir, why are you teaching us the human eye even if it's not there in our syllabus? Because that will help you to solve for other optical instrument. The magnification formula, do you remember? In which people are generally confused कि object is placed at the near point, object is placed far away, then formula changes, right? ये याद है आपको? Guys, have you done this chapter in your school? Hello?
So this year or 10th grade?
This year, 12th grade में.
No, our teacher didn't teach this part.
So if your teacher has taught this topic, then she might have done the derivations as well. And in the derivation, she might have placed once the object at the near point and once the object at the far away point, right?
Yes, sir.
Yes, sir.
Alpha, beta, and वो सब आता है ना यहाँ पे. Do you remember beta and alpha?
Yes, sir.
See, that will, this thing will help you in that. So that is why we are discussing this. Anyways, accommodation of human. ये homework है. I'm not discussing this. ये 10th grade stuff है. Please go through it. I'll discuss the defects by the way, and the numerical part involved in the defects. So what is basically accommodation of human eye? It is the process in which the eye lens adjusts its focal length depending on the position of the object to make the real image on retina by contraction or relaxation of ciliary muscles.
So this is important for JE.
Yes, it is. But not
Right.
accommodation, but abhi accommodation say I'll describe the the hypermetropia, myopia, and all things.
Oh, okay. Because this is not there for school syllabus.
I know, I know. इसलिए मैं समझा रहा हूँ ताकि वो फिर simple microscope and वो भी समझ में आए ना. When I'll be
Yeah,
using beta and
yeah.
alpha, I'll be defining, and I have to use the things with the logic.
Mm.
So, anyways, ciliary muscles is basically called as the power accommodation. Accommodation of human eye. Right? Always remember, when ciliary muscles are relaxed, then due to this thing we are able to see far away objects, and when ciliary muscles are contracted, we are able to see nearby objects. Okay? When ciliary muscles are relaxed, so lens will have a lesser focal length, right? Ciliary muscles, when they are relaxed, then lens has more focal length. So basically that's why the objects which are far away from each other can form an image over here. Yes or no? And when ciliary muscles are contracted, the lens becomes smaller in size. And basically it becomes thicker. When it becomes thicker, then the objects which are over here, they are able to see that particular thing. So lens and less focal. तो ये थोड़ा याद रखना है ना. It's related with bio. So anyways, now after defining this particular thing, there is something called as the range of vision. What is the range of vision? It's basically the distances till which you can write it is the range of distances till which an object can be placed so that a sharp image is formed on a retina. It is basically called as the range of vision. ठीक है? Basically the extremes, है ना? Always remember the extremities of the range of vision are basically called as what here? Are called as the far point and the near point.
Near point.
Okay, so far point is basically the greatest distance till which you are a normal eyes can see the object, and near point is basically the closest distance. At when far point is there, then serially the lens is basically the thinnest. I told lens has more focal length. Lens is thin when it sees far away object, and lens is thick when it sees nearby object. Always remember, guys. Ciliary muscles relaxed, lens becomes tense. If lens becomes tense, it has more focal length. Can you see? If it is becoming thin, then the curvature is less. If curvature is less, focal length is more, right? And when it becomes thick, what happens? The curvature becomes more, and due to which the range, the focal length becomes less. Is it clear, guys? Is it clear?
Yeah.
Take it. For a normal human eye, the range of vision is basically extending till where? For a normal human eye, the far point is basically infinity,
Infinity.
and the near point is basically 25 centimeter. This 25 centimeter is also called as the least distance of distinct vision. This 25 centimeter is basically called as what? The least distance of distinct vision. So here the range, in the case of a normal human eye, the range is from infinity to 25 centimeter. Or basically you can say 25 centimeter to infinity. You can let me just change where. Basically the range of vision is from 25 centimeter till infinity. ये लिख लेना. Let's start with the defects of the eye, है ना? Guys, all of you are aware of the defects of eye, right? Guys, are you aware of the defects?
Yes, sir.
Yeah.
I'll try to write it in short, है ना? First is called as myopia, also called as
Or sight.
short-sightedness.
Yeah, short
The name is short and short-sightedness. And basically, in case of myopia, we can see nearby objects, right?
Yes, sir.
We can see nearby objects. Far away objects appear to be blurred, right? Can anyone tell me why does an image seem to be blurred in the case of eye? If an image is appearing to be blurred, that implies the refracted rays inside eye are not falling over retina, right? Always remember, if you can't see anything, that implies the refracted rays inside your eyes are not falling over the retina. So in the case of myopia, what happens? Say, for example, suppose this is your retina, hai na? These are your retinal cells. So basically, two things can happen. The image may form in front of retina, or the image may form behind the retina, right? If it forms on the retina, then to tab dikhega hi, right? So two cases are there. In the case of myopia, the refracted rays, or basically you can say the image of the object far away forms in front of the retina. Okay, let me just draw in a copy the diagram from internet. Myopia diagram. Copy image. So guys, can you see over here? This is basically this is a myopic eye. Guys, can you see this particular thing over here? This diagram is basically myopic eye. And if I have an object which is at far away distance, so let's say if the object is at infinity, if the object is at infinity, then can you see over here the image forms where does the image forms? In front of retina, right? Yes or no? But in the case of the same myopic eye, if the object is situated at the far point is basically the till the maximum distance till which this myopic eye is able to see. So can you see when the object was at the far point, what did we do? The image forms on retina, right? Yes or no?
Yes, sir.
So basically, if I can just convert this case to this case somehow, can I say my myopic eye can be corrected? Can I say this? If I can convert this case to this case, I don't want this object to be at infinity. I want this object can be somehow, situated at my far point, then only I'll be able to see it, right? Up technically you can't bring the object to the far point to see it, right? ऐसा possible तो है नहीं practically, but you can bring the image of that object by using a concave lens. So basically, if I say if I want to correct a myopic eye, so I need to use a correction of myopic eye is basically to use a concave lens. Why this concave lens? Because will form the image of the object at infinity on its focus, right? So basically what we can do, we know this particular thing now. Concave lens will basically form the image of the object at which is at infinity on its focus. इतना सबको समझ में आता है ना कि basically we know a concave lens does this thing. The image of this thing will be formed here, virtual image. So we can adjust or make the lens in such a way that the far point of myopic eye lies on the focus of concave lens. Is it clear, guys? Did you understand the logic behind it? Guys, can everyone understand the logic behind it?
Yes, sir.
Anna? So basically with the help of this particular thing, what we can do, we can divert this light rays. For example, suppose this is not the, I can't, correct the diagram because this diagram is not correct. Suppose if the light rays are falling like from here, if you are drawing this diagram later at home, then draw the light rays over here, and after that do it like this. After that do it like this. Okay, then you can understand clearly that this light ray is basically diverge, and after diverging what happens, it forms a. So draw it like this. Okay, later on if you'll draw it. So you understood the logic, guys. Basically by using a concave lens we formed a virtual image just at the far point, and far point my eye was able to see. So basically you are not seeing the object. This concave lens is aiding you to see the image of that object. Is it clear? And basically you're not seeing the object, you're actually seeing its image. Is it clear? So this is how this thing is corrected. Not necessary this biconvex lens is used. Sometimes people use a concave or convex lens as more often, and you might have seen this lens as much more being used in specs. You might have seen a concave or convex lens, right? Oh, sorry, convexo concave lens. This is the generally used in specs for myopia, right? So if there is anyone who is having myopic eye, you might see your this thing. It generally has this form. It's a convexo concave lens, and it's diverging only. So is it clear? How we'll see the numerical part involved in the case of myopia? See, where was the object located? If someone wants to find out where is the object located for concave lens, है ना? Where is the object located for concave lens? For this concave lens, where is the object located? The object is at infinity. The u is basically infinity. And what is v? Where the image shall form? Guys, where the image shall form? Can you see this particular thing, that if this length is going to be very close to the eye, so I can say this length and this length, they are combined, right? Let this length do its own work. We just focus on what work this concave lens is doing. So can we say, if the object is at infinity, if I can form the image at the far point, if I can form the image at the far point, so basically what is df? Df is basically the distance of far point from eye, right? Yes or no, guys?
Yes, sir.
Hello. So df is basically what? The distance of far point from the eye. So image is there, object is there. I want to find out what is the focal length. I can apply lens formula. 1 by v minus 1 by u equals to 1 by f, right? So 1 by v is equals to 1 by minus df. 1 by u is basically equals to infinity. So can you see over here, from focal length is equals to minus of df. So the focal length of the concave lens which we are used shall be equal to what? The far point. So always note, this is how you will use this myopic eye in numericals, है ना? If it's a myopic eye, then अभी hypermetropic भी बताता हूँ. Do we have time? I think we have it. For a myopic eye, yeah, although we wrote the correction already, right? We can use the concave lens from the window, so we can adjust and make them in such a way that focal point of myopic line. Please remember to correct myopic eye, use a diverging lens, use any concave lens, na? Correct myopic eye, use a diverging concave lens of focal length equal to the distance of far point for myopic eye. Is it clear, guys? So this is about myopia. We'll discuss about hypermetropia now. In 10 minutes I can do it. And then remaining I can do it in the next class, I guess. What is there? Simple microscope, compound microscope, and astronomical microscope, right? Although I'll try to do this thing, I'll try to take a snapshot of these and update it already, because I'll be needing the images and it will take me time to draw these images. So I'll try to take a photo of these images. Okay. Anyways, Is this clear, guys? Any doubt in this?
No, sir.
The second part is basically hypermetropic eye. In the case of hypermetropic eye, what happens? Oh, sorry. Hypermetropia or long sightedness, or you can say far sightedness, right? So basically, in the case of hypermetropia, the name is long, and you can see till far away distances. है ना? We can see far away distances, but we can't see nearby objects. Or the nearby objects appear to be blurred. Why does it appear to be blurred? Because in the case of hypermetropia, or in case of hypermetropia, where is the image form? The image forms behind the retina. Okay, so the image forms behind the retina, or you can say the converging ability of eye is disabled, or not disabled, matlab affected. Converging ability of eye lens is weakened. Okay, so converging ability of the eye lens is weakened, and in the previous case, what will be weakened? The diverging ability will be weakened, right? So that's why it's converging more, diverging less. It should have diverged it to till over here, right? So anyways, so this is your hypermetropia. In the case of I forgot to tell you about the range in the case of metropia. Please remember, the range in the case of metropia is from where to where? The near point is basically what? The 25 centimeter, which is basically the least distance of distinct vision. And the far point is not infinity. Far point is till df. I'll come back to this later on. So anyways, similarly, in the case of here, range of vision. ऐसे नहीं करता मैं. If you have a normal eye, then this what will be the range for this normal eye? From this 25 centimeter to infinity. This is our range. Okay, for a myopic eye, the myopic eye can see this 25 centimeter object. So basically the least distance of distinct vision is still working, but infinity is not the range. The range is only till the far point. Are you getting my point, guys? The range has shortened. The range is only from where to where? I'll just shade it. This is the range in the case of normal eye. This is the range in the case of a myopic eye. समझ में आ रहा है guys? थोड़ा बहुत. In the case of hypermetropic eye, see what happens. In the case of hypermetropic eye, this 25 centimeter thingy you can see, no? This gets affected. So suppose if I have a hypermetropic eye, then if the object is placed at this 25 centimeter, then I won't be able to see it. I will be able to see it when the object is placed at the near point. Is it clear? So when the object is placed from the near point, then I'll be able to see it till where? Till infinity. So basically, what is the range of vision in this case? The range is basically from here to here. So can you see the range, guys? Any doubt in this particular thing? Can you see in the case of myopic eye, the far point shifts near to the eye. In the case of hypermetropic eye, the near point shifts away from that. Are you getting my point now? So basically, the range is from near point till infinity. This is the range, and I think I gave a good representation of this thing, right? Okay.
Yes, sir.
ठीक है. Just wait for some time. Hypermetropic diagrams. Copy image. Now, guys, can you see over here? When the object was at the near point, when the object is at near point 25 centimeter, the least distance of distinct vision, then our hypermetropic eye is not able to form an image. Where is the image form? Hypermetropic eye object at all of these diagrams are for hypermetropic eye, hai na? So when the object is at near point, the image forms behind the retina. Do we want this? No, we want the object to be, image form to be on the retina. So can you see when the object is at near point, when the object is at least distance of distinct vision, which is basically 25 centimeter, then the image is forming behind the retina. But can you see in this example, when object is at the near point, which is basically greater than 25 centimeter, then the image is forming on retina. Yes or no, guys? Can you see when this is where n is lying, right? Is it clear? Guys, is this clear?
Yes, sir.
Okay. Don't draw this one. Don't draw this part, na? Guys, don't draw this part. What I am telling you, draw that. Where exactly this n is, let this n be over there only. So let n be over here only. Can you see this n dash is over here? So n dash is over here. Don't draw this. Don't draw this dotted line. Okay. Now, if by any chance, if I can, say the light ray which is coming from this particular point get diverge away such that the image forms of, image forms at n dash. Are you getting my point, guys? Hello? If the image of this object which is at n, which is at 25 centimeter, if it forms at n dash, then my hypermetropic eye will be able to see it, right? So what is the correction for hypermetropic eye? Use a convex lens to form the image of object at least distance of distinct vision of basically 25 centimeter. Form the image of the object at 25 centimeter at the near point for the hypermetropic eye. So basically you form the image of this object which was situated at 25 centimeter. You draw the diagram like this, and I'll not draw the whole eye and all. So suppose make it like this. Wait. I know I'm making the diagram a little bit big, but it's okay. This is the eye lens, and from here the light rays are coming, and after reflection they should fall on the retina. Is it clear?
Yes, sir.
तो ये यहाँ से एक लाइट रे ऐसी आएगी and it shall go like this. Can you see it? It converges the light ray a little bit, and the remaining converging का part किसका पास? The remaining convergence, the eye lens did. So this is how you correct it. For the numerical part, for always remember, for concave lens, the object distance is basically what? Object distance is basically the least distance of distinct vision, generally 25 centimeter, but in some question it may be, they may give a different value, right? So D is basically the least distance of distinct vision. Where shall the image form? The image shall be formed at the near point. So basically this is the distance of near point. And what shall be the focal length then? So ये data याद रखना कि where exactly, because this is going to help you in doing any numerical based on hypermetropic eye or a myopic eye. So from here 1 by f will be equals to what? 1 by v minus 1 by u, and from here you can say it will be equals to u. So f will be equals to u into v upon u minus v, which will be minus d into dn minus dn divided by minus d minus dn. So from here when you will calculate, f will be equals to, can you see certain minus things will get, this minus and this minus will cancel out each other. This will become plus dn minus d, right? So your final answer will become dn into d divided by dn minus d. But please remember, when you use this formula without sign. Why without sign, sir? Because can you see this
So you
formula
already
has
used
to be,
sign convention.
because we use sign convention over here.
Hmm.
So that's why don't use sign convention over here. Okay? So always remember, for a hypermetropic eye, the focal length of the corrective lens is given by this. Is it clear?
Yes,
Is it
sir.
clear?
Yes,
In the
sir.
next class, I'll start with simple microscope, then compound microscope. I'll tell you what is that, this thing, alpha and beta. है ना? Alpha was for when the
Yeah.
object was placed at its original position, and basically beta is when, when the नहीं, when the image is placed at something like this. एक बार मेरे को भी देखना पड़ेगा.
Alpha is the angle subtended by the object, and beta is the angle subtended by the image, right?
Image, but when that image is placed where, at the object distance, I guess. ऐसा कुछ था, मेरे को याद नहीं आ रहा है, but अभी चलो, we'll continue in the next class.
Sir, can you explain the doubt now, or will you explain it on WhatsApp?
मैं अभी कर देता हूँ, कोई दिक्कत नहीं है.
Yeah.
Let me just take the attendance. Let me see who is absent today. Yes, who is absent? Joysha is there. Pavitra is here. Abel. Abel is absent. So Abel is absent. Who else? Guys, there should be one
Everyone
more.
else is here, I think.
Who?
I think everyone else is here.
Nine. There should be one is left. No, total should be 17, including me. There is one more. Ishita is not here. Okay. So Abel and Ishita. Okay. Chalo guys, thank you very much. We'll see you again.